Alright, so points x, y described by the equations x equals 1 plus 2t and y equals 3 plus t form a line. Is the point 7, 6 on this line? How about negative 3, 1, 6, 5.5, or 11, 7? So what you have to do is you have to take each equation, the x equals and the y equals, and for the x equals one, you have to put 7 in for x, and you have to solve for t, and for the other one, you have to put the 6 in the y, and then solve for t. So basically, you just put each one in for each equation, and you keep solving for t, and then so each one, and then if they're equal, like the first one, t equals 3 for both equations, then it's on the line, and then, so they're all...
Show what you did on that first one there.
So the first one...
Use that pointer.
He put 7 in for x, and then you have 7 is equal to 1 plus 2t, and then you have to solve for t, so then you subtract 1 from both sides, and then eventually you get t is equal to 3, and then for the other one you do 6, because that's the y value, is equal to 3 plus t, and then you get t equals 3, and since they're both equal to 3, then it's on the line. And so you keep doing that for each of them, and they're equal, so they're on the line. And then the last one, when you do it, t is equal to 5 for the x one, and t is equal to 4 for the y, so it's not on the line.
Perfect. To further clarify a little bit what Shelby said here, is if we made a table of this, you should have a table that has t values, x values, and y values. So for instance, your t value for the first one would be 3, with your x value being 7 and your y value being 6. That's what puts 7, 6 on the line. And we can keep on working through her work. She has t values of negative 2 here to give the x of negative 3 and 1. She has t value of 2.5. Gave the x value of 6 and the y value of 5.5. And then what she found is on the last one, to get the 11 for x, you have to plug a t value of 5 in, but then that did not give you the same thing. If I plug a 5 in to this, I get y equals 3 plus 5, which is 8. So 11, 8 is on the line, 11, 7 is not. Okay? Questions there?
I did nothing.
All right, so draw a triangle. Let's go.
Because if you don't press hard enough, it doesn't draw. Okay, so that's a right triangle.
Okay.
And we know that 2 of these have to be the same length.
Which 2 would they be in your picture?
This one and this one.
Okay, so what would you call the third side?
C, or the unknown.
They're all unknown. So here's my question. It's isosceles, so could you rename B something different?
A.
Do that.
Okay, which equals A.
Okay.
That's the
Now, using Pythagorean theorem with the 2 A's, solve for C. So C squared equals,
So C squared equals
A squared plus A squared.
A squared 2A squared? Yeah. That's how cool I am.
so what does C equal?
C equals something.
Well, you have C squared equals, so how are you going to get it to C by itself?
C equals 2A.
No, C equals A times the square root of 2.
Say that again.
C equals A times the square root of
slower.
The square root of C equals A times the square root of 2. A root 2. A.
How did you get that? That's 80 count.
Oh. Well, I was mainly listening to Aiden, and I wrote it. So.
How did you get that from the C squared equals 2A squared?
You get the square root. The square root is
So square root both sides?
Yes.
Okay. Jeremiah, take this little, on your iPad, the magnifying glass.
Oh, there it is. I was looking on the side. I had to
Now,
find
here, listen.
it.
Pinch like you're going to zoom in, or sorry, zoom out. And then move, and you just take it and move it up. Give more room. Okay? So let's do, now click back on maybe the red. Change colors here.
And then change colors. Oh, there we go.
Okay, so now you have, what's one side of the triangle? What's perimeter?
24.
Okay, what is the perimeter of a triangle? How do you find the perimeter of a triangle?
Side, side, side.
So if I ask you again, how to find the perimeter of a triangle, you're going to say side, side, side.
No, yes.
What's the perimeter?
A plus B squared equals no.
Okay. Guys, quiet please. Can somebody please raise your hand and tell Jeremiah how to find the area of, the perimeter of a triangle?
You add all the sides up together.
Side, side, side.
side plus side plus side plus side. What's the difference?
So why don't you add all the sides up right now?
So 3A, I'm thinking, times that.
Okay.
That's
Where'd you get the, why don't you erase that?
okay. I'm just gonna
Where
go.
did you get the,
Is that not back? Okay, so erase the whole thing.
yeah, all the red.
Okay.
Here's the problem, is you said there's 3A, you can't add. You, without trying to do it all in your head, you just write out the equation.
Which equation?
Add up the three sides together.
Okay, so A plus A plus C which equals
Wouldn't C be A times root 2?
yeah, that's what I was kind of thinking earlier, which is why I wrote 3A times
I'd rather you not write the 3A, but I'd rather you do that with the A root 2 on there.
A. So it'd be A plus A root 2. Okay. Man, this is very fun to use.
It takes a lot of finger dexterity.
It works.
Okay, what does that equal? What should that
3A
equal?
root 2.
3A root 2.
What's the perimeter of the triangle?
Oh, 24. So I'm going to zoom out again. Zoom out. Scoot it this way. And then erase that.
It won't
Erase.
erase when you zoom out, by the way.
It won't.
It's just an equal sign.
Oh. Equals 24.
Okay. So, now can somebody tell me what would A plus A root 2 equal? What can you simplify that to? It's not 3 times root 3A times root 2.
2A plus A root 2? Maybe.
Write that down. equals.
24.
Yep. What do 2a and a root 2 have in common?
2.
A.
Factor it out the front. Factor it out to the front. Factor.
Divide by 2. Oh, okay.
Factor a.
I don't know. He just said divide by 2.
Who said that?
Aiden.
So I put something at the same time as Aiden. You trusted Aiden.
He's closer, and I don't understand what you're like meaning. Factor this variable. I mean. Okay, so you would get rid of this, and you would divide by a. I'm thinking not.
Put A out in front. Put A out in front and parentheses 2 times root 2. Is that right?
So A out in front.
Yeah.
In front of that hole. Like that. In front, I mean. I am special, thank you.
Put the whole thing divide by A.
This is
Jeremiah, whole equation parentheses says A.
Alright, so now.
Yay. Doing a pause?
Yes, please. Maddie, can you explain what I should do now? You were right.
What it means by factor out is take out the A from the equation, so it'd be A times the quantity of 2 times root 2.
2 times root 2?
Or 2 root 2. No, yeah, 2 times root 2. No? No, 2. Oh, 2.
Because we have, if we factor,
Oh, right.
hold on.
The x and y coordinates of a point are given by the equations below. Use your graph paper to plot points corresponding to t equals -1, 0, and 2. These points should appear to be collinear. Convince yourself that this is the case and calculate the slope of the line. The displayed equations are called parametric, and t is called a parameter. How is the slope of a line determined from its parametric equations? Well, what I did is I plugged the points corresponding to t equals -1, 0, and 2 into both of the equations, and I got the numbers, like these ones, and I graphed them, and I determined the slope, and I got the slope as 2/3.
Okay, so can you show, put on the red ink.
Okay.
Okay, good. Now, circle, like when you plugged in a -1, what your answer was.
-7. And for y, I got -1.
So where's that point?
Point is right here.
Okay, go ahead and label that one -7. And then label the other 2 points what you got for them too.
Okay. Oops. Oh goodness. Okay.
Okay, so you plugged in a -1, a 0, and a 2, and you got those points, right? Now how'd you find the 2/3 with that?
I calculated the slope by counting the
units up and across, and using those in the equation.
So your up was 2?
Yeah,
And your over
it's
is
3.
3. Okay, let's just pause. What we're looking for, and this is the easy way, we can go through with parametric equations. We can graph them and find the slopes with the graph. Can anybody see a pattern from these equations and the slope she got here? Maddie.
The 2 from the y is the rise, and the 3 from the x is the run.
Yes. So notice, here's my y. This is my y, right? Over x. Over x. That makes sense? So, let's just double check that you're understanding here. If I had parametric equations that look like this, x equals 4t minus 3, and y equals 7t plus 8. If you graph those, what's the slope of that line? 7 over 4. It's a t-values. I tricked you. I put the t-values first. Okay, good. Yes, Levi.
Did you get the answers for the quiz?
Find parametric equations to describe the line that goes through the points a equals 5, negative 3, and b equals 7, 1. There is more than one correct answer to this equation, or this question. So Hannah plotted the points here and here, and we found the equation y equals 2x minus 13. So the slope would be 2 over 1. So we did y equals 2t minus 3, and x equals t plus 5.
How'd you get the 5 and the negative 3 at the end of your
We plugged in the points 5 and negative 3. Or no, we plugged in 0 for t, and then we used point A for...
And solve for the b.
Yeah.
Okay. Questions there?
Show that the triangle formed by the lines y equals 2x minus 7, x plus 2y equals 16, and 3x plus y equals 13 is isosceles. Show also that the lengths of the sides of this triangle fit the Pythagorean equation. Can you identify the right angle just by looking at the equation? Well, first of all, I just turned that equation and that equation into slope-intercept form. Then I graphed it, and then I found the slopes of it, and that this is the right angle because these two slopes are opposite. And then
opposite?
or reciprocals.
Okay, go ahead.
Reciprocals. And then I used the Pythagorean theorem to find the hypotenuse of each, and it is an isosceles. But you can't ID a right angle by looking at it because it could be barely off by like a little bit.
Okay, so I think our question though was, not just by looking at the triangle, but could you,
Oh,
with
the
the equations, figure out if it's a right triangle?
Yeah,
Yeah, how would you do that?
because if the two slopes of two of the equations were reciprocals or opposite reciprocals,
Right.
then they would be perpendicular, and two lines that are perpendicular create a right angle.
Perfect. All right.
A triangle has vertices A equals 1, 2, right there. B equals 3, negative 5, right there. And C equals 6, 1, right there. Triangle A prime, B prime, C prime is obtained by sliding the triangle ABC 5 units to the right and let's see, where was I? 5 units to the right and 3 units up. It is also customary to say that vector 5, 3 has been used to translate triangle ABC. What are the coordinates of A prime, B prime, and C prime? By the way, C prime is the usual way of reading C prime. Okay, so A starts out at 1, 2, so you move that to the right 5, which would turn the x from 1 to 6, and you bring it up 3, which turns the 2 into 5, right there. And then the b was at 3, negative 5, which you bring it to the right 5, which would turn it into 8, and then bring it up 3, which would turn it into negative 2. Oh, wow, Levi, I forgot something else. Negative. Oops. Oh, well. That's good enough. Okay. And then C is 6, 1. So you bring it to the right 5, which makes it 11, and up 3, which makes it 4.
Okay, continuation of 8. When vector HK is used to translate triangle ABC, it is found that the image of vertex A is negative 3, 7. What are the images of vertices B and C? Well, what I did is that from the original points of A and B and C, you can translate it. You can let's see. You can say, what was the original points? The original points of A. Oh, it's up there. Okay. 1 and 2. You can. Where's the pointer?
You already got it.
Right there, 1 and 2, and then you can find a slope or whatever, a vector, which is 4, 5, and then you can find the points of from B right here and get B prime, and then the point for B prime is negative 1, 0 with the vector.
Hey, Michael, can you select on one of the inks right there? Ink colors.
Right there, like
yeah,
red.
Any one of those, and then plot the point negative 3, 7.
Negative 3, 7. There's not a. Oh wait, I got it. Somewhere right there.
You sure?
Nope. Shh.
You goose. You call him a goose.
All right.
Yeah.
So that point is negative 3, 7. So show how you figured out. What are you doing?
Trying to write B prime, whatever. Or whatever.
Worse than Jeremiah.
Or what is that?
Oh.
Shh. That's it. Okay. I thought it was B. Okay.
Okay, so show where you got the negative 4 and 5 from.
Well, from here, hold on, pointer. From here, wow.
It's a little, has a little
Target right there. Okay. From here to here, it's a vector of negative 4 and 5.
Because you go where?
You go down 4 over 5. Right? I mean left 4 of 5. Yeah.
Okay. So then how'd you get B prime and C prime?
Let's see. It's from here, and then you do the same thing with these points. You go 4 left, up 5. So from B right here, somewhere right there, you go 1, 2, 3, 4, and then you go up. What was it? I got negative 1, 0 right there. That's B. And then from here, you go left 4, up 5. So that point was right here. So 2 and 6. And then it makes translated triangle. There we go.
All right.